This video covers section 1.1 of chapter 1, where we get into the basic ideas of statistics and focus on sampling methods. Now, to start off, statistics is the study of procedures for collecting, describing, and drawing conclusions from data. That's what we'll be doing in this class. Now, in statistics, we often study populations and samples. A population consists of the entire collection of individuals being studied, everyone we want to study, whereas a sample is just a subset of that population. But of course, it always contains people who are being studied. Now, a lot of times we want to understand an aspect of a population, but for various reasons, we can't actually collect data from every single member of a population. Pause the video for just 10 seconds and think about why. It's because collecting data from a large population can be really prohibitively costly, time-consuming, and or impossible. So what we do is we take a sample of that population and analyze that data and try to make an inference about the population based on the sample. So that means that we need to focus on ways to take effective samples from a population. And that's what we're going to be learning in this section. And so we're going to have this guiding example, example 1. Pause the video and just read it, and then unpause it, and we'll continue. So the most basic sample, in a certain sense, is called a simple random sample, which is also abbreviated SRS. I might talk about an SRS. The book might talk about an SRS. And it means a simple random sample. Now, technically speaking, we need to be a little more specific. We say a simple random sample of size n, right? Meaning that n people or n individuals are being sampled. So, for example, if we wanted to conduct a simple random sample of size 50, for example 1, well, how would we do it? Now, pause the video for a second, think about it. It might not be quite as simple as you might think, even though simple is in the name. So you might just think, oh, look at the apples and randomly pick 50 of them. Well, okay, but how are you really making sure that every apple has an equal chance of being chosen? What you would really need to do is number the apples 1 to 1,000, and then use a random number generator. Use a random number, that says number, generator to choose 50, well, that says 50 random numbers. Then choose the 50 corresponding apples. So this would actually take a little bit of time, right? Numbering all 1,000 apples, or ordering them in such a way that you could see which is the first and which is the 1,000th, etc. But that would be a true, simple, random sample. Right? So then again, that takes a little bit of time and, might cost a bit, whatever. Is there an easier sampling method? Well, pause the video and read example 2. So what do those two samples have in common? Well, number one, I think they're both quite a bit easier than the method we just described above. In particular, these methods are both, you could say easy, but I'll use the word convenient and perhaps at least as importantly, they are both potentially biased, meaning that they might favor one group over another. They might represent one group more than others might be represented. A convenience sample is a sample that is not drawn by a specific methodology. All right, just whatever seems to be the most convenient. Right, they're done out of ease or necessity. So just think about the question at the bottom of your screen. Again, maybe take a sec to think about it. And just think, what are the pros and cons of convenience samples? Just think about it. We're going to move on. Now, here's an example. Pause and read example 3. What might be, not necessarily wrong, but what might be problematic with a simple random sample, and what might be a better way to do it? Well, I'm going to use red for this. Well, if you think about it, a simple random sample might potentially underrepresent women, or just in general, it might not properly represent women, right? They're a smaller group. If those 100 women all have a concern that's not shared by the 300 men, then because they're a smaller group, a simple random sample might not properly capture their voice, or it might not give the appropriate amount of weight to their concern. So if you really just care about proportional representation, then probably a simple random sample is fine. But if you want to make sure that smaller groups are heard, maybe you want to make an extra effort to ensure that they're heard, you might want to choose a different sampling method from a simple random sample. So a simple random sample could undervalue women's thoughts. If the company wants to value men's and women's concerns equally, then it should sample an equal number of men and women, or something similar to that, for example. And so that leads us to the next type of sampling, a stratified sample. Right? It's a sample in which individuals are first grouped into, groups, or the fancy term is strata, which is where we come up with the name stratified. Right? And then each stratum is randomly sampled. Right? Now, again, one of the pros to this is the example above. But there are cons. So spend a few minutes and think about the pros and cons to stratified sampling. We're going to move on. So read example 4. Is this a stratified sample? And the answer is no. because not all hospitals are sampled. We'll just say sampled from. It's kind of a weird way to say it, but we don't sample from all hospitals. I should say, all sampled individuals come from 5 hospitals, right? I'll say 5 hospitals, the 5 that were chosen, right? Now, maybe the hospitals were randomly chosen, but still, once those 5 hospitals were chosen, only those hospital residents were sampled, not residents from the other 43. Okay, so this is called a cluster sample, right? In which individuals are grouped into, you guessed it, clusters, and then all individuals in each cluster are sampled. And you can think about the pros and cons to that method. And now, quickly read example 5. Is this simple random sampling? You might say, well, yeah, it's going to be a random choice, but that's not quite right. There is definitely randomness to this method, but the answer is no. Because, well, I guess I'll just say each bottle after the first is, I guess I'll just say, predetermined. And what I mean by that is that if we decide to choose every 5th soda bottle, then we know that we're going to be choosing bottles number 1, and then number 6, and then number 11, 16, etc. Right? We're never going to be choosing the 5th bottle. We're never going to be choosing the 7th bottle if we start with bottle number 1. Right? So that's why this is not the same thing as a simple random sample. This is what's called a systematic sample. Right? Good with, factory lines or line of products. There are, of course, pros and cons that you, of course, should think about. And then this is something I will do frequently in class. I will call on you. But suppose I were using this for data collection, right? I just said, what music do you listen to, right? What kind of a sample is that? Well, it's not quite the same as anything we've talked about before. You could call it a convenience sample. You wouldn't be wrong for saying that. But it's a little more specific. You can call this, it's called a voluntary response sample. Right, in which the sample individuals are people who, volunteer to be sampled. And you can probably imagine some pros and cons with this type of sampling. They might overlap quite a bit with the pros and cons of convenience sampling, since this is kind of a type of convenience sample. But try to come up with some ones that apply only to volunteer response. Okay, so those are all the different kinds of samples that we have, the different kinds of sampling techniques that we have that we're going to look at. One last thing is that a characteristic of a sample is called a statistic. You've seen that word before. And a characteristic of a population is called a parameter. Okay, so a lot of times we want to find out what a parameter really is. But we can't do it, and so we settle for finding statistics and then use those statistics to make an inference about the parameter.